Okay, this is the M1 paper from June 2023. It's question number 2. This question involves forces which are in equilibrium. These forces are set up as vectors, but let's read through it and check what we've got to do. So we've got a particle P resting in equilibrium, and we've got 3 forces acting on it. F1 and F2 you can see there, and F3 we need to work out in terms of C, I and J. So let's do that first part because that's really straightforward. Make it clear to the examiner. If they're in equilibrium, then F1 plus F2 plus F3 must work out to be equal to 0. So F1 is 3Ci and 4Cj. F2 is minus 14I plus 7J. And then plus F3 must equal 0. So let's just tidy that all up in terms of the i's. I've got 3C minus 14I. With the j's, I've got 4C plus 7. So just tidy that up. J plus F3 is equal to 0. So F3 is just the negative of all that, so I can write that down as 14 minus 3Ci, and then I can say minus 4C plus 7J there. So F3 in terms of C's, I's and J's, all done. It then says, situation changes, F3 is removed from the system, and we're told that C is equal to 2. And then it says find the size of the angle between I and the direction of the resultant force. Okay, well, it means find the resultant force first of all, doesn't it? So for part B, the resultant force is going to be F1 plus F2 now. So F1 plus F2, it was 3Ci plus 4Cj, and it was minus 14I plus 7J, but we know that C is equal to 2 in the question, so that's 6I, 8J, minus 14I, plus 7J. So that all tidies up to minus 8I plus 15J. Now what do they ask us? They say, can we find the size of the angle that this vector makes with I? So the direction I, let's draw that out on a diagram then. So we know where I is. I is going to be just in that direction there. There's I. But my vector, if it's minus 8I plus 15J, I don't need to draw it accurately, but I need to draw it in the right quadrant of where it would be. That's what minus 8I plus 15J would look like. This is minus 8I here and 15J there. And they want this angle here. Theta, I can't work that out yet, but what I can do is I can work out alpha there because that's just using SOHCAHTOA. So tan alpha is equal to 15 over 8, which means that alpha works out to be 61.93 degrees. And if that's true, theta is 180 minus 61.93. So that works out to be 118.07 degrees for theta. Did it say anything about how accurately it wanted it? No, it didn't say anything, so I can leave it as that if I need to. And while we're here, let's have a look at part C then. So it says the mass of P is going to be m. If we know that the acceleration of P, or rather the magnitude of the acceleration of P, is 8.5, can we work out the value of m? So yeah, we can. What we need to do first of all is to say for part C, if F worked out to be minus 8I plus 15J, then what's the magnitude of F? The magnitude of F is simply going to be the square root of 8 squared plus 15 squared. That works out to be equal to 17. And then we know F is equal to MA, and in this case, in terms of magnitude, 17 is equal to 8.5 times m, so m will be 17 divided by 8.5, well that works out to be equal to 2, so 17 divided by 8.5, m works out to be equal to 2. So again, relatively straightforward question number 2, hopefully that will make sense to you.